Okay, let's look at this question here from this this paper right here. So this is a pretty easy question of resultant force. We just have to calculate of the forces in each direction, x and y, on both sides. Because the arrows are pointing upwards on y and right side on x, the point where the arrows are pointed at, the direction, that direction is going to be positive, and completely opposite of that is going to be negative. So because it's here x in the right side, left side is going to be negative. So it means that we can easily use this technique to find out the first part, which says the resultant force in the x direction is 0. So this part right here, if we let this be a right angle triangle, then we can use the component rule to find out that this equals to 25 cos 60 and this is 25 sin 60. I'm doing sin 60 right now. I'm in the vertical direction because I will need it for the next part. Here we have 10 cos alpha, here we have 10 sin alpha. I'll just assume the fact that on the vertical axis, on the vertical direction we have sin, and on the horizontal direction we have cos. So in that case you also have here similarly 20 sin 30, 20 cosine 30. So we can now just do the following. Add these two vectors up, add these two resultant force up to get the following. So because it says resultant force in the x direction is 0, 25 cos 60 plus 10 cos alpha minus 20 cos 30, this equals to 0. So what I'm going to try to do is I'm just going to try to make 10 cos alpha the subject, because I know that I will be needing this one. So I'll get 20 cos 30 minus 25 cos 60. Now the best trick to do is that instead of simplifying this a whole lot, I could just try to put this whole thing on the calculator, or even more simply I could just try to write cos alpha equals to 20 cos 30 minus 25 cos 60 divided by 10, this whole thing divided by 10, and then I can just do alpha equals to cos inverse this whole thing directly. Let me show you. I'm going to do cos inverse of this whole thing directly. So that's what I'm going to do right now. Just hold on a minute. And yes, indeed, we get 61.18 degrees according to the mark scheme. I actually did the calculation there, as you can see, and also it matches with the mark scheme. So this is what I've done here. Now it is better to do it in this way rather than just to simplify that and write root 3 by 2.5 or anything. But yeah, we got the angle alpha. Next up we need to find out the magnitude. The magnitude happens to be the resultant force, right? So the resultant force is going to be this one. The resultant force is 0 and the magnitude is going to be the following. It's 4 marks, so it's pretty big, way too big. So we just need to find out the components in both x direction and y direction. So in x direction we have 10 sine 61.18 plus 25, not 10 sine, is 10 cos 61.18 plus 25 sin 60. Actually, you know what, I won't need this one because you know that in x direction is 0, so we only need the y direction. So in y direction we have 20 sin 30, 10 cos alpha plus 25 sin 60. So 10 sin alpha, so 10 sin 61.18 plus 20 sin 30 minus 25 sine 60. Whatever we get here, we are going to do the following. The magnitude is going to be x square plus y square. X square we know is 0, so we can just do y square, which can be found by just doing this whole thing as a magnitude. So we get, as a result, a big number. Whole square. Now we can substitute this one directly to the calculator and we will be able to get an answer. Let me show you. We get something 2.9. What's your answer? 2.89. That's correct. So 2.89 newtons. That's correct. So our alpha is going to be this one and our magnitude is going to be this one. So that's that. Next up we have to find this exact same thing, but this time when alpha equals to 45. So if alpha equals to 45, we now need to find out the resultant force. So resultant of the three forces. What we do is that we just try to find it out on both the x direction and y direction. So we know that on the x direction it's going to be as follows. So in the x direction, what we have to do is that we just have to find out this following. 10 sine alpha is this case, 10 cos alpha plus 25 cos 60 minus 20 sine 30. So we have 10 sine 45 plus 25 sine 60 minus 20 sine 30. So if we get a positive here, we know that we are going to get in the positive direction. I mean, things like that will actually help us to determine which quadrant is that going to be, which will allow us to easily find out this using the trigonometric ratios, which I'll come back to in a bit. And then we have y, which is going to be 10 sine alpha plus 20 sine 30 minus 25 sine 60. So we have 10 sine alpha, actually it's going to be 10 cos alpha, because we know that in x direction we have found out all of them to have cos alpha. So cos, 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 and here is going to be 10 sine alpha plus 20 sine 30 minus 25 sine 60. So therefore we have some values here which you have to check using a calculator. However, we are not going to write down the value that we get from a calculator yet, okay, because we need to make sure that our answer is as accurate as possible. I mean, we need to make sure that we can use the accurate values or the accurate expressions until we get on to the final answer, and then we can approximate our answers then. But in this case, you are not going to approximate it right away. So we have 10 sine 45 plus 20 sine 30 minus 25 sine 60. We get a negative, which means that it's going to be in the negative axis. I'll just note it down right here, negative. And for this one, 10 cos 45 plus 25 cos 60 minus 20 cos 30. We get 2.250. So it means that it's going to be getting here underneath. So it's going to be in the third quadrant. So it means that our triangle, our right angle triangle, will kind of look like this. It's going to go underneath in the downward direction while moving towards the right. So it's going to look like this. This is angle theta, and this is going to be the x direction, this is going to be the y direction. So our theta can be found easily if you happen to know this is the opposite and this is the adjacent. So we can use the tan ratio. So tan theta equals to opposite y plus 20 sine 30 minus 25 sine 60 divided by 10 cos 45 plus 25 cos 60 minus 20 cos 30. So 25 cos 60 minus 20 cos 30. So this whole thing I'm going to just actually need to do the following. I'm going to shift this a bit towards the right, and then I'm going to copy this entire thing, and then just going to make a copy, as you can see. So this whole thing I'm going to paste it here, and this thing I'm going to move a bit towards the right so that I can write the tan inverse thing right here. So this thing, tan inverse this whole thing to get our answer. So we get in this case minus 63.82. Okay, so that's because we are in the negative side, so we're going to get 63.82. we're going to ignore the negative sign and we just get the answer. And then finally what we do is we try to find out the resultant magnitude. So the magnitude is going to be the square root of this thing this thing squared plus this thing squared, the denominator. Copy, paste. I'm going to try to make it even smaller. Paste this thing squared. So I mean it's super small, so it is just hard to read. But you see, the magnet is going to be the two directions. I mean the component forces summed. I mean the squared. These two are squared, and then the squares are summed. So we get here the following. I'm going to look at the answer a bit later for matching. So we get 5.10. What does the mark scheme say? 5.10. Okay, so it's going to be 5.10 Newton. So because I'm writing it in theta right here, I actually realize that I also have to write it down normally here. So the angle alpha is correct here, so nothing is wrong here. But in this case, for our angle theta, I just realized I need to write it in a bearing form, because we know that we have to give our direction. We cannot just give our angle theta. So it's going to be somewhere here, let's say. So I'm just going to do in a bearing form, which is much easier. So bearing is going to be 90 plus 63.82. 63.82 is going to be 153.82 degrees bearing. So we can give it in any notation. So it says below positive x-axis, but I like to use the bearing notation. But yeah, if you are feeling too risky about it, you can just try to do it in the way you can just try to do it in a masking way, which is at the fourth quadrant or below x-axis, and for this one it is as it is. So yeah, that's basically how you can do this question. Pretty lengthy but quite easy.